Hi, welcome to Module 3, Submodule 2, Lab 2C. In the final lab on temperature and humidity sensing, we're going to create a program that triggers an output based on the sensor input. This is where we can start applying our skills to creating smarter devices. In this case, we'll be turning on an LED when the temperature gets above some temperature and turning it off when it falls below some temperature. One thing that we'll be learning from this is how temperature can be controlled. If you remember, if you can turn an LED on, you can turn anything on. That's why engineering is sexy. No, but seriously, if the temperature reaches a certain set point, our program can take an action like turning on a fan, cooling device, opening a window, etc. This is basically how a thermostat works. But more broadly, understanding how to access sensors and then using that information to craft a response is how smart devices work. Rather than turning an LED on, we can also send out an email, a text message, or ping a server on the internet. For wildlife, something like this becomes useful when you have to monitor the environment where an animal is being kept and make sure the temperature remains in a comfortable zone. It can also be used to trigger a fan or refrigerator pump if you have to store samples in a controlled environment. This gets us into the fascinating topic of remote environmental monitoring, but that comes later. For this lab, we'll be using things we've already learned, but combining them in different ways. We'll also be using conditional statements for the first time in this series. If you've ever done any kind of programming, you've likely ran into conditional statements. Those are the if, then, else statements. It's mainly the same thing, and if they're new to you, I recommend reviewing the links in Module 2, where we put links on the basics of C++ and Arduino programming. Let's get started. Now let's get into the code. First, we're going to start by including the DHT sensor library. Then we create our DHT object and specify the pin we'll be accessing it from, A0, and the sensor type. Now we're going to create a variable called threshold, which is the temperature threshold we're going to set our alarm for. If it goes above this threshold, we'll turn on an LED and print out a warning message. Let's set this to 26 degrees Celsius. The reason we set it as a variable is so that if we need to, we can change it easily later here at the top of the code. We're also going to set a variable for the LED pin we'll be using to turn on the LED. Again, we do this in case we want to change the LED pin later. In this case, we'll use the LED on pin 4. In the setup, we first set up the LED. To do this, we use the pin mode function and set our variable pin LED to output. Then we can do a digital write to that pin and set it low. This means it's turned off. Now we call our dht.begin function to initialize our sensor. After that is our serial.begin with our baud rate, and finally we print out our title header. In the loop function, we create a floating point variable called temperature and assign it the return value of our read temperature function. Now we use our conditional statement. If the temperature we read is above our threshold temperature, we print out a warning message and turn on our LED. If we read the temperature and find that it's less than or equal to our threshold, we stop printing warning messages and turn off the LED. Finally, we print out our temperature in a nicely formatted way so that we can watch how our temperature changes. We also add a delay to our loop function so that we only check the temperature once per second. That's our program. We mainly check the temperature, and if it's above our threshold, we turn on the LED and print out a warning message. Let's give it a test compile to see if there are any errors. Now let's upload it to our board. In testing the system, you can see that we're below our threshold temperature value. If we want to raise the temperature, we can grab the sensor and squeeze it inside our hand. it'll be warmed by our body heat, which is around 37 degrees Celsius. When the temperature reading goes above our target temperature, the LED will turn on and our warning messages will start getting printed out. And once the temperature goes below our threshold value, the LED turns off and our warning messages go away. In this submodule, we learned how to access the DHT11 temperature and humidity sensor, create commands to access the sensor on demand, and also how we could use the sensor input to trigger a specific action. In the next submodule, we'll be learning how to measure the battery status using the analog to digital converter. Stay tuned for Module 3, Submodule 3, Measuring Battery Status.